Morning students, I am K. Manohar, Assistant Professor of Chemistry, Vigyan Institute of Technology and Science. Today we will discuss the experiment determination of viscosity of castor oil and groundnut oil by using Ostwalds Viscometere. The aim of this particular experiment is to determine the viscosity of the given any solution. Okay. To perform this experiment, we require some apparatus and chemicals, and principle involved in the experiment. Okay. Let us see what are the apparatus using in the experiment. So, these are the apparatus are required to perform our experiment. So, first one is Ostwalds Viscometere. So, this is the Ostwalds Viscometere, U-shaped glass tube which contains two bulbs. One is higher bulb and one is a small bulb. So, in this bulb we have to fill the test solution up to this particular mark, that is mark A and mark B. So, this is a lower mark is called as a B, mark B. Upper mark is the mark A and B. Okay. So, this is Ostwalds Viscometere. By using this instrument, we can determine the viscosity of the any given solution, and we require specific gravity bottle. So, it is a specific gravity bottle. The use of the specific gravity bottle is to measure the mass of the given liquid solution by specific 50 ml of liquid solution. And third one is the stop clock. So, it is a stop clock or stopwatch to measure the time requirement. So, how much of time taken. So, to follow the solution from mark A to mark B in Ostwalds Viscometere. So, that is the use of the stop clock. And fourth one is the measuring jar. Fifth, weighing balance. So, the chemicals required to perform our experiment is, first one is the standard solution. Here we are taking standard solution is water. Water is the standard solution. And second solution is the test solution, any test solution. Here I am taking the test solution is castor oil, and this is a test solution, and in this experiment we are using the formula is like this way. So, here neta 1 by neta 2 is equal to T1 D1 by T2 D2, where neta 1 is the viscosity of the standard solution, that is nothing but the water molecule. So, that value is specific, that one is 1.009 grams per cc, and where T1 is the time taken, how much of time taken, that is taken to flow the water from mark A to mark B in a viscometer is called as a T1, that is for test water molecule, is called as a in seconds. We are measuring the time is in seconds, and D1 is the density of the standard solution. Here the density of the standard solution is specific one, that is 1 grams per cc, and whereas neta 2 is the viscosity of the test solution, this must be unknown. That means we have to find out the test solution viscosity, given test solution viscosity, that should be measured by using the Ostwalds Viscometere, that is unknown one, and T2 is the time taken to flow the water, the test solution from mark A to mark B in Ostwalds Viscometere, that can be represented by the in T2 in seconds, and D2 is the density of the test solution. Density of the test solution is equal to D2. Here the procedure to perform our experiment is like this way. So, first we have to take the Ostwalds Viscometere and fill the water, fill with water, that nothing but it is a standard solution. The standard solution I am taking water molecule and fill the water molecule in a Ostwalds Viscometere like this way. First we have to put a one finger at the one side and fill it in a water molecule in Ostwalds Viscometere up to this particular mark is called as the A mark, upper level of the bubble, and release this finger and measure the time, how much of time will be taking. So, from the mark A to mark B, the liquid once if it is flowing from the mark A to mark B, how much of time that will be taking is can be measured with the help of the stopwatch, and you have to record this particular time in a tabular form like this way. Here these are the table. This table contains trial, standard solution time and test solution time. So, standard solution time is T1 in seconds, test solution time is T2 in seconds. So, in a first trial, so we have to fill the water in a bubble and release the finger. So, the time will be counted by using the stopwatch, and that time you have to record in a table. So, the first trial, in a first trial I am getting 17 seconds of time. Similarly, if you are going for the second trial, again you have to fill the water up to certain level and release the finger and measure that particular time, how much of time is taking to fall the water from mark A to mark B. And in a second trial I am getting the time is 18 seconds. Similarly, do the third time, go for the third time, third trial I am getting 19 seconds, and cumulatively you have to go for the average time of the standard solution. Here I am getting the average time of the water flow from mark A to mark B is equal to 18 seconds. And similarly, in a second trial, second test solution, you have to take the test solution in place of water. So, you have to remove all the water and fill with test solution with a similar fashion. So, put a finger at the one side and pour it in a second side. So, up to A mark and release the finger and measure the time, how much of time will be required to flow the water from mark A to mark B. That time you have to record in a table in the second column, that is the third column in time, time in seconds. Here I am getting in first trial, that is 37 seconds. So, similarly go for the second trial, third trial. So, here I am getting the time is 32 and 36. Similarly, you have to take the average of all the three trials. So, you will get a 36 seconds of time. So, to flow the test solution from mark A to mark B. Here these are the tables. So, in this table here we are taking the some summary, that is trial, standard solution T1, test solution T2 in seconds. So, here the average time of the test solution is 36 seconds and standard solution is 18 seconds. So, these results you have to submit in our formula or principle. What is the principle here? Neta 1 by neta 2 is equal to T1 D1 by T2 D2, where here T1 and T2 are the time taken for the liquid solution from A to B level. T1 is the standard solution time and T2 is the test solution time requirement. So, you have to substitute in this result, you will get a neta 1 and a neta 2 values. Here we have a one more calculation, that calculation to calculate the density of the test solution as well as the standard solution. So, to find out the density of the test solution, so first we have to take the specific gravity bottle, and weigh it by using the weighing balance, that like this way. So, the empty bottle weight here I am writing as a W1. W1 is equal to weight of the empty bottle density is equal to 27.44 grams. And here in a W2, the W2 is nothing but the once if you are taking the 50 ml of liquid solution or any test solution. So, liquid solution plus empty bottle weight, again weigh it by using the balance, and you will get a W2 weight. That weight equal to weight of test solution plus empty bottle is equal to 66.73 grams per cc. And you have to remove this particular test solution and you will get a accurate the test solution weight that may be calculated as a W3 is equal to weight of test solution. We will get a by W2 minus W1. W2 minus W1, you will get a accurate the weight of the test solution, that may be mass. So, mass equal to W2 minus W1, 66.73 minus 27, I am getting 39.29 grams per cc. And here this value I am substituting in the equation. That equation is neta 1 by neta 2 equal to T1 by T1 D1 by T2 D2. But our aim of the experiment is to calculate neta 2. So, neta 2 equal to T1 D1 by T2 D2 into neta 1, and substitute all the equations, all the values in a equation is equal to T1. What is T1? The time taken for the standard solution. What is a standard solution? How much of time is taking? That is 18 seconds. Then I am substituting here 18. And D1 is the density of the standard solution. The density of the standard solution is 0.99 grams per cc. I am substituting here. And by 36, T2 is the 36. Why we are taking as a 36? Because of the test solution time taken. So, to fall from the mark A to mark B is 36. So, then I am substituting the 36 into D2. D2 is the density of the test solution that can be calculated by using the weighing machine is equal to 0.78 into neta 1. What is neta 1? Neta 1 is the viscosity of the standard solution, that value is 1.0019. Then substituting in the equation by doing the simplification, we will get the value of neta 2, that is nothing but the viscosity of the test solution is equal to 0.3932 CPS, where CPS is the centipoise, it is the units for viscosity of the any given solution. So, from this experiment we can find out the viscosity of the any given solution in the place of the castor oil. So, that is a experiment. Thank you.